Hello, it's Mr. Schwannekamp. Hope you are doing well. We're getting close to the end of the semester. I know we're starting to wear down. We've got this lesson and related rates, and that's really it. So we're getting close. All right. I know you're getting tired. Stay with me. This is all going to help you next year as we work through it. Just keep working through it with me. All right. We're doing well. Today we are doing inverse trig derivatives, and the main idea here today is memorization. If you can do some memorization, you're going to do pretty well. Okay, we're going to kind of show you where things come from, but if you can memorize, you'll do fine. Let's look at these first couple ones to begin with, and then I'll turn off my camera, but I figured you might as well want to see me. You don't get to see me anymore. Inverse sine, if we were taking the derivative of inverse sine. Okay, not sine, but inverse sine. The derivative of inverse sine is 1 over the square root of 1 minus the baby squared. So whatever's inside the parentheses, that's the baby. Okay, that's the argument here that we're going to square. So whatever's in there, we're going to square that, and then we're going to multiply by the derivative of the baby. So this is really a chain rule problem. You can kind of see the theme here with implicit and with these, they're all kind of chain rule questions. All right, so it's 1 over the square root of 1 minus the baby squared times the derivative of the baby. You need to know that one. Okay, this is definitely one that's going to be on AP exams. Okay, inverse cosine might be on the AP exam, probably not. But if they did, if you memorize inverse sine, inverse cosine is the same thing. It doesn't change anything. Oh, the only difference, there's negative sign in front. Everything else is the same. 1 over the square root of 1 minus the baby squared times the derivative of the baby. That's it, same thing. Okay, those two are important. The other one that's important is inverse cotangent. Inverse tangent. That one's also going to be on the AP exam. Okay, notice that it's very similar to inverse sine. There are two differences between inverse sine and inverse tangent. Okay, one of them is it does not have a square root sign, no square root. The other difference is it is a plus sign instead of a minus. That's it. So inverse tangent is 1 over 1 plus the baby squared times the derivative of the baby. Again, something you need to start memorizing. Get those in your brain. Okay, if you know inverse tangent, inverse cotangent, probably not on the AP exam. If it were, it's the same. Only difference, there's a negative sign in front. Boom, that's it. 1 over 1 plus the baby squared times the derivative of the baby. Same as inverse tangent, just with a negative sign. Inverse secant and inverse cosecant, I have definitely not on the AB exam. They might throw it on the BC exam. I don't expect them to. This would be something like, hey, it's the day before the test. Let's remember inverse secant, inverse cosecant. That's about as deep as you would want to get. It's 1 over the absolute value of the square root of the baby squared minus 1 times the derivative of the baby. And then cosecant, you got a negative sign. There they are. You can come back and look at those. We're going to spend most of our time today with inverse sine and inverse tangent. All right, so that's where we're headed. Again, it's more memorization than anything else. Let's start this thing off with just showing you that this is a thing. Okay, let's say that you forgot how to do the inverse sine or how to take the derivative of inverse sine. Technically, you could do this problem without it. So let's take the derivative a different way. So inverse sine. Let's say I wanted to get x by itself because I don't know what inverse sine is. So what I could do is I could take the sine of both sides. So I could make this sine of y, and if I take the sine of inverse sine, that would cancel. Sine of y is equal to x. That is something I could do. And then we could say, all right, well, I know how to take the derivative of sine, so let's take the derivative of sine and x. So what's the derivative of sine y? Well, that would be cosine y. We rewrote the baby, and then we would have to multiply by the derivative of y, just like we do with an implicit. Okay, and what's the derivative of x? Well, the derivative of x is 1. So we took those derivatives. That was easy, just like we've always done. No real difference there. Okay, but we want to solve for y. We want to get y by itself. Okay, or dy dx by itself. Sorry, I want to get the derivative by itself. So how could I get that by itself? Well, I could take both sides and divide by cosine y. That's going to cancel. So dy over dx is equal to 1 over cosine y, which is good, but that isn't in terms of x, it's in terms of y, and we are all worried about taking the derivative of their terms to x. So what could we do with it? Well, think back to our Pythagorean identities. We know that sine squared plus cosine squared is equal to 1. So sine squared y plus cosine squared y is equal to 1. So if I got cosine by itself, I could subtract sine squared and take the square root. Okay, so this is a true statement. If I have cosine y like I do right here, I could replace that with this. So dy over dx is equal to 1 over the square root of 1 minus sine squared y. Well, how does that help us here? Well, look right here. We've got sine of y squared. Well, what could I put instead of sine of y? The sine of y is equal to x. The sine of y is equal to x, so that means dy over dx is equal to 1 over the square root of 1 minus x squared. We just did a substitution there. That is where inverse sine derivative comes from. Do you need to memorize that? No, but I thought I would show it to you because it's cool. All right, let's do it. Most of the time, these problems are pretty easy. Y is equal to that. We are trying to find y prime. Y prime, that's 1 over the square root of 1 minus the baby squared. That is how we take the derivative inverse sine. Okay, we just set that thing up over there. Cool. All we got left to do is plug in the baby and multiply by the derivative of the baby. What's the derivative of x squared? 2x. Done. That's my answer. Okay, obviously you could write 2x on top if you wanted to get fancy and write that 1 minus x to the fourth. Who cares? Same thing. Okay, we don't need to simplify that. Good, that's one. Let's look at example 2. Example 2, we're taking the derivative of inverse tangent. We've got some multiple choice answers here, so we can kind of check our work as we go. But let's do it. Take the derivative inverse tangent. Well, what's the derivative inverse tangent? That would be 1 over 1 plus the baby squared. So in this case, my baby is just x times the derivative of x would just be 1. Cool. Got that first part, so it's not A, it's not B, it's not C. None of those make any sense. It's either D or E. Plus the derivative of 2 squared of x, so that's 2x to the 1/2 power. Multiply by a half, so that'd be 1. And then I would subtract 1. So if I subtract 1, it'd be negative 1/2. X to the negative 1/2. That's the same thing as 1 over the square root of x. That's E. Easy. Easy peasy. Let's go to the backside. Just a heads up here. One of the first things they say on the AP test is they have this disclaimer. It's the only thing they say. It'll say this: the inverse of a trigonometric function may be indicated using the inverse function notation of inverse thing like that, little f to the negative 1, okay? Or they could use arc. So inverse sine or arc sine. You've seen that from me because I do it pretty heavy when I teach you pre-calc because I want you to know that. But inverse sine and arc sine, those mean the same thing, so don't get overwhelmed with that. We're taking the derivative of inverse cosine, so y prime. Inverse cosine, well, that's 1 over the square root of 1 minus the baby squared. Oh no, that's inverse sine. What's different about inverse cosine? There's a negative sign. Plug back in the baby, and then multiply by the derivative baby. There's my answer. Obviously, we could simplify if we wanted to. Oh, I didn't mean to put this x here, sorry. The derivative of 7x is just 7. We could leave it like that, or obviously we could do this good deal here of 1 minus 49x squared. Same thing. Both of them are the same. You don't have to simplify if you don't want to. This would be a multiple choice question. Arctangent, we're taking the derivative of arctangent of the square root of x. Okay, arctangent. So y prime equals 1 over 1 plus the baby squared. Let's plug in the baby. So the baby, I'm going to write x to the 1/2 power because I like that instead of square root. And I'm going to take the derivative of that, so I'm going to multiply by a half. Subtract 1 from my exponent. That's my answer. I'm going to clean it up a little bit. 1 over, I've got a 1/2 that's being multiplied, so I'm going to throw a 2 in front. X to the negative 1/2, so I'm going to throw a square root of x in front. Times, this would just be 1 plus x to the 1/2 squared. That would just be x. That is my cleaned up form. That's what it would be looking like on a free response question. Or multiple choice question, sorry. All right, let's go to example 5. So this is something that I was going to spend more time on this semester, but we're at home. So I have not spent a lot of time doing this. Looking at example 5, a good time to talk about this. If the limit as h approaches 0 of arc sine of a plus h minus arc sine of a all over h is equal to 2. Okay, so think about that. What does that look like? The limit as h approaches 0. When you see this right here, an alarm should be going off in your head. Okay, oh, the limit as h approaches 0, that is the limit definition of a derivative. Or in other words, f prime of x, that's what we're finding here. We're finding the derivative is going to be equal to 2. That's what that means. That's what it's telling you. The limit as h approaches 0 is 2. So which of the following could be a value of a? A is the x value. So really it's f prime of a is equal to 2 is what that's really telling me. All right, well, what is f of x? What is my function that's being stated here? Remember, it's the limit as x approaches a of f of x plus h minus f of x all over h. Now, this is f of x right there, sine of a, or in other words, sine of x. That's my function. F prime of a is all equal to 2. Well, let's find out what f prime of x is. Let's find f prime of x. I want to know the derivative of sine. Well, the derivative of sine is 1 over the square root of 1 minus the baby squared times the derivative of the baby. Well, it's just this. And I know that this answer right here, that this derivative, when I plug in a, is going to be equal to 2. And so my job here is to solve for a. So a lot of different things going on here. One thing I hate is fractions. So I'm going to start off by getting rid of this guy. So to get rid of that guy, I'm going to multiply both sides by the square root of 1 minus a squared. I'm going to write that again so it's not quite so thick because I can't really see it. The square root of 1 minus a squared. So if I multiply this side by the square root of 1 minus a squared, it's going to cancel. That side, it's that. Cool, so that's gone. Now I've got 1 equals 2 square root of 1 minus a squared. I'm trying to get a by itself, so I'm going to divide by 2. I'm going to get rid of the square root. So to get rid of the square root, I'm going to square both sides. So 1/2 squared is going to be 1/4, 1 minus a squared. I don't want it to have the 1, so I'm going to subtract 1. 1/4 minus 1 is negative 3/4. I'm going to get rid of the negative sign. I'm going to get rid of the square. I'm going to get for my final answer, square root of 3 all over 2 is equal to a. Answer is B. Square root of 3/2. And I'm done. A little bit weird, but this is just understanding, hey, the derivative of an inverse, or I'm sorry, my brain just stopped working. That is a derivative question. It's a derivative in disguise. In fact, if you want some more practice with that, which would not be a bad idea, I would look up on Khan Academy, AP Calculus, derivatives in disguise. There is a section on that's a pretty good understanding of those questions. Those are ones that are always kind of tricky to kids. I didn't teach you a specific lesson over that this year, and I would have in the past. Okay, last thing, arc cosine of 5x to the 4th. All right, cool. We're finding y prime. 1 over square root of 1 minus the baby squared. My baby's 5x to the 4th. The derivative of that of 5x to the 4th would be 20x cubed. Oh no, it's arc cosine. So what else do I need to include? No negative in front. There we go. That is inverse trig derivatives. It's memorization. Okay, if you can memorize these two things right here, these two guys right here, you are going to be successful. Okay, there's no real tricks to it. It's memorization, and that's it. Okay, this proof thing up front, fancy. You don't need it. Okay, this last question, if that one threw you off, cool. It wasn't what I taught you today that was throwing you off. It was the other stuff. All right, so for most part, not too bad. If you have questions, come to the Zoom. I will talk to you then. Have a good one.